well, we don't have the amount of bacteria we started with, but R is not relative to where you started. It's relative to how much time has passed since some other amount of bacteria existed. So the relative growth rate is time dependent, but you can start at any point. So we pretended that we started with 800 bacteria. This is number 4. And after, 10 minutes after that 800 bacteria, we ended up with 3,911 bacteria. So we have 10 minutes later, 3,911 bacteria. So you can use this equation to solve for R.
And that's because you started out with 800?
We didn't really, but we pretended. We had 800
Oh,
at 15
at
minutes.
15 minutes, we
And
wanna
so
know
we
about
said, okay,
25.
we're gonna take this as our starting point in order to calculate the R part.
Okay.
And so then to finish solving this, what do we do? Divide by 800, so we have 3,911 divided by 800 equals e to the R times 10. And then next, change to logarithmic form, so it'll be natural log of 3,911 divided by 800 equals R times 10. And then end by dividing by 10, so we have the natural log of 3,911 divided by 800, all of that divided by 10, and this pen has had it. So that is our R. You can type this into WebWork, yes. When it says with at least 5 decimal places after the point entered correctly, that's got at least 5. It's got them all. Now, you are going to need this R to answer further questions. Anytime you calculate an R that you're going to need to use later, I would recommend you store it in your calculator. How do you store a number in your calculator? Anybody know? Yeah, you have a lovely little store button. So while I'm at it, I'm going to store this one. Natural log of 2011. You hit your store button, and it's usually standard to store under using letters. So the next button you probably want to hit is your alpha button, and then pick a letter you like. Personally, since this is R, I pick R.
What are we doing now?
We're storing this number in our calculator because we're going to need it again.
Okay, so you do.
And then after you pick your R, you hit enter, and that is stored as your R.
Once we enter it in?
Yeah. Yeah, STR. And then alpha. The letter R is over here by the multiplication sign. So now, we're going to use this again, and by the way, you need, although you can round to put your answer here, you cannot round and still get correct answers in the rest of the spaces. So you want to use accurate numbers for your exact number, which is what we stored for R, in order to do the rest of the calculations. So now we want to find the initial size of the culture. Well, this time we can't pretend we started with 800. We actually have to figure out where we really did start. So we can use that after 15 minutes we had 800 bacteria. So we had 800 bacteria. This is what we started with. Our R we know is the natural log of 3,911 divided by 800 over 10. And then we had 800 after 15 minutes. So I can divide my 800 by this mess, which is just a number, to find out how many bacteria I had. That's 10, right? Times 15. And that'll tell me what P is. But here's the deal. The number of bacteria has to be what? Has to be a whole number. And I got bad news for you. Paul's problem, at least, didn't let you round either direction, not yours, the other one. Because he emailed me and said, well, here's my answer. I was like, yeah, I'd only let you round one way. Let's see. One of yours did that too?
Yeah.
Alpha times 15. So my problem comes out, this comes out to be 74.010483887. So the initial number of bacteria is actually 74. And then this needs to be a whole number. You will now be able to answer the rest of the questions using 74 as your initial number of bacteria, this R as an exact number, and then you can plug in what you need, where you need it. So what would you do, so here's the model you're using, by the way. A equals minus 74 times e to the natural log of 3911 over 800
So how do we know that 15 is
divided by 10 times t. The 15 matched up with the 800 in the problem, given in the problem.
Oh, okay, so is that 0.15? I can't.
No, it's times 15.
Oh, okay. Normally I use parentheses.
Yes.
The double period, would that go for 50 minutes?
No.
Okay, so
I don't know what the
8
doubling
times
period
15,
is.
right?
To find the doubling period, what do we need to do? Double what? Double P. P was originally 74. We double that, we get 148. We'll put that here, and then we figure out what T is. And that'll tell us how long it takes to get to twice as many as we started with. What? Right, we doubled this, because the doubling period asks how long does it take to double what you have? And so this is what we started with. So when we double it, we will have twice as many, or 148. And then we solve for T the same way we solved for R in this
Why
process.
do I get
So,
46?
we still keep 74 over there?
Yes, the 74 is still here, because this is the model. So we'll plug in to A 148,
So we bring it over.
and then we bring it over to be 1 half. Yeah, it'll be 2.
2 equals.
2 equals this thing, and then we change to logarithmic form. For the population after 90 minutes, that takes even less work, plug 90 in for T. And when will the population reach 13,000? We plug 13,000 in here and solve just like we did for R here, or for the doubling period when we did the doubling one. You're gonna get really tired of solving for those exponents before you're done with these problems.
Which one, the double?
Okay, you got tired of them.